So we are working on the parallel smart contract layer on Bitcoin. So we think Bitcoin it deserves something better, even better than Ethereum. So we are starting from the scalability. So I was working in Microsoft research decades. I heard this term for a decade in this industry. And we're starting from the single chain scale up, multi-chain, and roll up, recently roll ups. But for all these systems that we have today, if we have a single contract, we're still working on a single instance of EVM. So this is the current stage. And what's the problem? So do we really have the scalability over so many years? But it's not. So there is a lot of problem behind the thing. But so today I will cover two of them. So the first is we lack of computing resource. So it is not we don't have money to buy more computer. The thing is all the smart contracts is working on a limited programming model that it's restricted every single smart contract to be single-threaded, and it's running sequential. Another problem is that actually for the infrastructure builder, it's kind of lack motivation to really build something scalable. And if we look at all the monetization model today we have, so it's if you have higher throughput, so you have more capability to process more transactions. It means the transaction is not less crowded, so you have lower gas revenue. So this is the problem. It's a paradox. So do all these infrastructure builder want to build something really fast? So for both directions, there is projects pioneered in both directions. And so for the computing resource, so till today, we eventually see projects that's working on, we put a single smart contract and make it run. At least we have multiple threads instead of single thread on a single computer. It's pioneered by Z Labs and Monet, but till now it's limited to 2x scalability. And another side, so the info builder, it's lack of motivation, and so there is a direction that we for the Aptos and the SUI. What they are doing, they provide first-class assets. This is a very interesting, program model. So allow the user-defined assets to be treated as the first-class citizen on the blockchain system. But it's just for security, and we think it can be, something more. And yeah, today I present Bitrex. So for the computing side, we provide a linear scalability that is you can achieve more speed with more EVMs running on the internal network. And another side, we support first-class assets as well. But in our system, the first-class assets is used not only for security, but also it's provide more monetization model. So Bitrex, it is a Bitcoin layer 2 network providing a parallel smart contract layer and with first-class assets. So like many other layer 2, we do the merge mining, we do pigging Bitcoin to the layer 2 to provide liquidity. And there is two key differentiation on our platform. The first thing is, so they are all supported by a novel programming model. So there is very few people talking about the programming model. So this is the fundamental how we program a smart contract, how we write code. So here is the thing. We provide a linear scalability, so we can do parallelization based on the PREDA programming model. And also we provide first-class assets based on the programming model. It's called PREDA. So currently, the Solidity rules work. So it's almost 93% smart contract is developed by Solidity. Solidity is a huge success. It's along the way to push our industry to the scale we have today. But but this is also put some difficulty, to have disruptive innovation happen with the strong ecosystem. So in this menu, we are talking about the Bitcoin layer 2. We saw on Bitcoin, it is lacking, a smart contract platform. So we saw this is a great opportunity to have the sandbox, have the new stage for, truly disruptive innovation on smart contract platform to happen on top of the Bitcoin. So what's the problem with the Solidity? So it's something missing here. So for Solidity, for every smart contract built by Solidity, it exposes no data dependency. It works like a black box. You don't know what code is accessing its read or write, what part of the on-chain state. So it's a nightmare for parallelization. And also, in Solidity, ERC20 is actually a normal smart contract for the perspective of blockchain system. I mean the underlying system, they even don't know ERC20 is assets. It's representing assets, and they don't know ERC20 is carrying great value. So with this situation, the DApp prosperity, it's not equal to more infrastructure revenue. So this is a problem. So let's talk first about the parallelization. So in Bitrex, so parallelization is not just having more EVMs on the chain. Previously, we're talking about blockchain scalability, right? So it's a Polkadot near. It's also we rollups, but it allows smart contract to be deployed on only one VM. But there is so many VM, so we can support a lot of smart contract. But if you have a smart contract that's really popular, there's a lot of transaction around it. It's have to fit into a single EVM. But in our model, on Bitrex, we allow a smart contract to be deployed on all instances of EVM you have in the network, and the transaction will be dispatched to one of the EVM to be processed, so that each smart contract on Bitrex, it is able to leverage the entire throughput and capacity of the network. So here is the simple code showing Bitrex is not introducing something crazy. It's just simple annotation to the Solidity code. So there's the blue part. So it's describe how we divide the on-chain state and how the state is how the divided state has been read or write. Just with all these like four lines of code is it's additional annotation. So with that, so this is what we can achieve. So it's comparing with the recent narrative about the parallel EVM on Ethereum. So for parallel EVM, for this well-known project we have, they are all based on software transaction memory. So they are all based on optimistic parallelization. What is optimistic? So they just guess. They just guess if the multi-thread read and write of the state will be conflict. It's just guess, and by lucky. So if it's conflicted, they have to roll back. So there's a problem that, so if you have more EVM to supporting the system, the possibility of rollback will be much higher. So this fundamentally restricts the scalability STM can achieve. So here in this diagram, it's just a tiny line here. It's about 1.4x to 2x scalability. But with the PREDA model, so we have a little bit modification to the Solidity language, and able to expose all the data dependency so that we can achieve deterministic parallelization, is that you will never need to roll back. There will be no conflict when you read and write chain state in parallel. So with this, we can achieve linear scalability that we can, for example, here in this diagram with 64 parallel EVMs. So we can achieve, we tested on different types of smart applications. So there is, it's almost at least for 40 x, and something is 50x. So this is it's the scalability also, the overall speed can get greater when you leveraging more EVMs. Yeah, and another feature is first-class assets. So this is a new paradigm of assets that, so that there is on the language level, it is a type representing assets, and their amounts can only be moved from one instance to another. So basically, you have a type. They provide only one function that's transfer from one instance to another. So it's fundamentally, on the programming level, avoid the double spending. And beyond, security feature, first-class assets provided, it actually, allow the underlying system to trace the assets movement, and the assets can be held by any smart contract instead of the smart contract is define the assets. So also the assets can be passed around across all the multiple EVMs. And the last thing is that for you, if you have a wallet, right, you sign a transaction to do some DeFi things, and you can control ETH, you can control the spend of ETH, but right now you cannot control all the ERC20 tokens. But with first-class assets, it can be controlled. You can set a maximum bound of how many ERC20 tokens to be spent, like the Ethereum. So basically, FCA provide a way to decouple that a smart contract is doing the bank and doing the mintage. So with the FCA, any smart contract can be the bank, and any smart contract can be the mintage with the authorization. So it provides a new monetization model that since the underlying blockchain system have trace of all these movement of all the assets, so it can be automatically develop a field of code that's doing something like a revenue share and collaborates with the DApp and the infra builder. So this is a more natural and healthy model that a infrastructure can keep going and provide more throughput and capacity, and share the prosperity from all the dApps. So the overall architecture of our system is like this. The top layer is all the applications, and the apps FCA token will be defined there and will be minted there and will be transferred there. But in the middle layer is the parallel execution engine. It's a multi-instance of EVMs or PREDA VMs. So this is our name for the EVM. And the FCA transaction with FCA and all the contracts holding FCA will be aware by this VM, and even will be aware by the network that's transferring data, broadcast all these transactions. So this is a way that we can set up a rule and to share the revenue from the DM to the infrastructure. And yeah, further, so takeaways. So the Bitrex is focused on, we have to let the smart contract being parallelized to deliver scalable transaction and capacity. and the first-class assets. So it's provided a new way to monetize infrastructure and lets the DEX, the DeFi, more flexible way to program. So that's it. Thank you.